Great. Good afternoon, good morning, good evening, everyone. Thank you for joining again. My name is Joe Donahue. I work for a company called Apt Associates. Apt is, as Aditi said, a contractor for the U.S. Environmental Protection Agency. And we've been supporting the EPA in its role as a lead partner in the Climate and Clean Air Coalition's waste initiative for several years now. Among other things, we assist EPA in developing tools for the initiative, and today I'm going to provide an introduction to the Solid Waste Emissions Estimation Tool, or SWEET. This is a new tool that we are just now finalizing version 1. This presentation is meant to be an introduction to the tool. It is not going to be a formal or rigorous tutorial or training on how to use the tool. Those opportunities will be available in the future, but for now we're going to focus on just introducing you to SWEET. So in this presentation I'm going to provide some brief background information to help you understand why we developed this tool. I will provide an overview of the tool, including a brief description of how it is designed and what its purpose is. I'll talk through some slides that explain how to use the tool and including some examples that help illustrate how you can, what types of scenarios you can analyze using SWEET. And then lastly, I will provide some information on how you can access SWEET and obtain assistance in using it. So most of the people on this webinar are probably already familiar with what short-lived climate pollutants are, but I think it's useful for us to take a step back and just make sure that we're all on even footing when it comes to talking about short-lived climate pollutants, because they are one of the primary motivating factors behind the development of the SWEET tool. So when we talk about short-lived climate pollutants, we're talking about a subset of greenhouse gases and aerosols that have a strong impact on climate. They remain in the atmosphere for short periods of time compared to long-lived greenhouse gases such as carbon dioxide, which can remain in the atmosphere for thousands of years. And SLCPs, in addition to contributing to climate change, they have detrimental impacts on human health, agriculture, and ecosystems. Considering their strong impact on climate and health and other sectors and their short atmospheric lifetime, studies have looked at the near-term benefits of reducing SLCP emissions, and a recent, or a kind of a seminal UNEP study, that's the United Nations Environment Program study that came out about 5 years ago, estimated that by achieving near-term reductions in short-lived climate pollutants, we could avoid 0.6 of a degree Celsius in warming in 2050. We can avoid 2.4 million premature deaths from reduced pollution in 2030 and 52 million metric tons of avoided annual crop losses in 2030. You can find more information on the benefits of reducing SLCP emissions at the link that's on the bottom of this page. When we're looking at the solid waste sector, the two SLCPs that we are primarily interested in are black carbon and methane. These are they're very different. They're very different substances. They are common in that they both have very strong impacts on climate and human health, but they come from different sources and they have different influences on climate and health. So black carbon is it's a component of particulate matter, and it's formed as a byproduct of incomplete combustion of fossil fuels, biofuels, and biomass. It remains in the atmosphere for only days to weeks, and it has a significant impact on climate. Studies suggest that black carbon is second only to carbon dioxide in terms of total radiative forcing, which is the primary determinant of climate impacts. And black carbon contributes to the same health impacts as fine particulate matter. Methane, on the other hand, is produced by anaerobic decomposition of organic material, such as organic waste in landfills or dump sites. Some of the key drivers that influence methane emissions from these sites include the amount of organic waste deposited, the extent of anaerobic decomposition, cover properties, and oxidation rates. Atmospheric lifetime for methane is about 12 years, and again, it's a significant climate forcer. After carbon dioxide and black carbon, methane is the third most significant contributor to total radiative forcing. Methane is not an air pollutant itself, but it contributes to the formation of tropospheric ozone, which is an air pollutant. It's important to understand or to think about the significance of methane and black carbon emissions from the waste sector in the broader scheme. So when we look at black carbon, it's important to know that it's very unclear how much the waste sector contributes to total emissions. And this is primarily due to the fact that there's very little there are very few studies that look comprehensively at emissions of black carbon from the waste sector. Most of these emissions sources, including open burning, landfill fires, are sources that are hard to measure and quantify. So there isn't a whole lot of literature out there. But the US EPA estimates that the waste sector accounts for about 0.5% of global emissions of black carbon. That said, this estimate does not include emissions from waste collection fleets, which are covered in a different piece of the pie chart that you see here on the right. Those fall under transport. So presumably the waste sector accounts for more than 0.5% of global black carbon emissions, but again, it's very uncertain. With methane, the contribution of the waste sector is better understood. The EPA estimates that the waste sector accounts for approximately 12% of global methane emissions. This primarily comes from landfills and dump sites. And landfills and dump sites, they represent the third most significant anthropogenic, so man-made source of methane emissions globally. Now, when you think about methane and black carbon, even if there's some uncertainty about the total magnitude of the impact of the waste sector on global methane and black carbon emissions, it's very clear that both of these pollutants have strong impacts on local health and global climate. So there's a strong interest in understanding the magnitude of the emissions from different practices or activities or technologies used in the waste sector. But understanding or estimating those emissions is challenging for a number of reasons. First of all, we have a lack of data for many of the activities that contribute to these emissions. As I mentioned before, waste burning is one that is one activity where there is very little data or only anecdotal data from a few global regions. Waste composition is we usually have incomplete information about the composition of the waste in many of the cities that are involved in the waste initiative. And then lastly, we have many cities don't have complete data about the amount of fuel consumed or miles driven by their collection vehicles, and this is a challenge for estimating emissions. Secondly, we have there's a general lack of emissions factors for certain sector sources. For example, looking at open burning again, there's a high variability in emissions factors for garbage burning depending on your global region, your waste composition, the combustion conditions, And this lack of emissions factors makes it difficult to come up with project or city-specific estimates of pollutants. Third, disposal site methane generation and emissions rates are not measured in many instances. We can model methane generation and emissions from landfills and dumps, but there are very few instances where there are active real-time monitoring systems in place to capture data that can be used to validate those models. So there's high uncertainty. And lastly, calculating these emissions in a comprehensive and consistent manner is complicated, especially the case for landfills, where there are a large number of variables involved. Okay, now I'd like to introduce the suite tool, and you see here a cover shot. This is what the front page of the tool looks like. So recognizing the challenges involved in estimating emissions of short-lived climate pollutants from the waste sector, and also the importance of trying to understand the magnitude of these emissions so that we can come up with or identify best opportunities for mitigating them, the US EPA has began developing the solid waste emissions estimation tool, or suite, on behalf of the CCAC Waste Initiative. This is an Excel-based tool for quantifying emissions from sources across the sector. It can provide project-level, source-level, or system-level emissions estimates. And when I say source level, I mean, by source I mean waste collection and transportation as opposed to landfills and dump sites. And you'll see a little bit more what we mean by sources later in this presentation. Suite can provide or estimate emissions for a baseline scenario and up to 4 alternative scenarios if the user chooses to analyze alternatives. And the tool is designed to account for emissions of, first of all, black carbon and methane. Those are the two SLCPs that we are primarily interested in with the CCAC. But it also accounts for co-emitted pollutants, including carbon dioxide, NOx, and SOx, particulate matter, and organic carbon. Organic carbon, like black carbon, is a component of fine particulate matter, but it has very different properties or atmospheric effects. For example, black carbon contributes to a warming effect on climate, whereas organic carbon has a cooling effect. So accounting for not just black carbon and methane, but also the full stream of pollutants is important for when you're looking at total net climate mitigation benefits. And that's why we've chosen to include organic carbon and these other pollutants. So this table provides an overview of the sources that we look at in the suite tool. The first row is not really a source. It's more just to make it clear that the tool requires you to provide some general information that is used across all the other sources, and some of the required inputs that are needed for this tool in the general information category include waste generation and collection rates, the city's population, and the waste composition for the general waste stream. For landfills and dump sites, and this tool can handle up to 4 disposal sites under each scenario. For landfills and dump sites, some of the examples of required inputs include the amount of waste going to each disposal site, the composition of the waste going to the landfill, depth of the landfill or dump site, when the site opened and closed or is expected to close, and whether there's a gas collection system in place. And I should say that for the waste composition, I mentioned earlier in this presentation that many of the cities that work with the CCAC don't always have a great or complete data about the composition of their waste streams. So the tool actually provides some assistance in entering that data. There are default values that users can rely on. When we look at waste collection and transport, the number of required inputs is quite a bit smaller than for landfills and dump sites. We only require that you provide the number of trucks of different types, whether they're heavy-duty trucks or light-duty trucks or gasoline versus diesel. And the tool actually, we also account for trucks that use compressed natural gas, which we know is not really a popular fuel at this time, but we know there is a lot of interest in the possibility of capturing landfill gas and converting it to CNG to use in collection fleets. So we've incorporated that into the tool. For waste burning, the tool requires users to estimate the percentage of waste that is burned either in the open or at landfills and dump sites. And there's some guidance in the tool on how to come up with those estimates. Again, this is an area where there is very little data. So we understand that for the most part, cities will be making educated guesses based on their experience rather than using the results of dedicated studies that have looked at this topic. For waste handling, we ask users to enter the number of bulldozers, excavators, compactors, and other large equipment that's used to manage the waste at landfills, dump sites, and other facilities. For organic waste management facilities, we ask users to provide the quantity of waste going to the different facilities, whether it be composting or biogas projects. We ask for an estimate of the composition of the waste that goes to those facilities. So the composition of the waste that goes to a compost facility is going to very likely be different from the composition of the waste going to your landfill. So we want to distinguish between those waste streams. And then for waste combustion, we only ask the user to provide the amount of waste going to a combustion facility, so whether it's mass burn or RDF, and also a reject rate. So if you can estimate 5 or 10% of the waste going to the facility is ultimately rejected because it is inert waste or rocks or dirt. So those are the emission sources and some examples of required inputs. These are not all the inputs that are required, but this is a fairly representative sample of what you will see in the tool. In terms of outputs, Suite generates emissions of pollutants and presents them in terms of metric tons and also metric tons of carbon dioxide equivalent. Only pollutants that are either greenhouse gases or otherwise have an impact on climate can be converted into carbon dioxide equivalent. So we wanted to provide both metrics. The estimates are also presented for each individual source, as in addition to the entire waste sector. They're presented in tables and graphs and separated by scenario, whether it's baseline or one of the 4 alternative scenarios. The outputs generated from this tool, the emissions outputs, can be used for a variety of purposes. First and foremost, these outputs are useful for analyzing the air quality and climate change impacts or benefits of different policies or projects or programs. And by enabling users to understand the impacts on air quality, we're also moving a step towards potentially enabling the quantification of health benefits from improvements to waste management. This is something that the Waste Initiative has been thinking about for a while, and several of the partners involved in the Waste Initiative have been exploring opportunities to link waste management improvements to health benefits. The outputs from this tool can also be used to estimate the contribution of waste management improvements to city emissions reduction goals. So if your city has adopted a goal of reducing its CO2 equivalent emissions by 25% by 2025, for example, you could use this tool to determine how far you can get towards that goal by converting your dump site to a landfill and beginning to capture landfill gas. The tool can also be used to track performance and compare cities. Also, it can be used to evaluate alternative waste management scenarios and practices, and it can help inform decisions about capital investments. The tool was designed using information and data from a range of EPA studies and guidelines, other peer-reviewed studies, and various other credible sources. The emissions calculations are based on established methods, including methods promoted by the IPCC emissions inventory guidelines, and also methods that were that are available through tools that have been developed by the EPA and the Global Methane Initiative. Many of the assumptions, or all of the assumptions and the sources behind those assumptions are fully documented in the tool. We want this, the information that goes into the calculations to be as transparent as possible. There's some caveats or limitations to the suite tool that users should be aware of. First of all, this is a very important point, the emissions estimates should be considered preliminary. Even the best estimates using the best available methods and data have a high degree of uncertainty. And this is something, we don't want cities using the results of the suite tool to develop bid tenders or making investments based on the outputs from this tool alone. The outputs from the suite tool should be used as to inform decision making, but not necessarily direct it. Second, the default values that are used in this tool may not be applicable to all cities. We used the best available information we could find to provide default values in instances where we felt that cities would have difficulty using their own or coming up with their own locally specific inputs. But we realize that many of these default values may not be applicable in all geographic regions or in all urban environments, so we've made it possible for users to override those default values. Third, the tool is currently available in English only. We understand that that's a limitation for many cities, and we're thinking about how we might address this in the future. The tool does not account for indirect CO2 emissions or emissions reductions, for example, from recycling activities or from incinerating waste to generate electricity as opposed to using fossil fuel-based electricity generation. Right now, the tool does not allow users to gradually phase in changes. So if you want to model a gradual conversion of your collection fleet from diesel trucks to CNG trucks, the tool cannot do that right now. What it can do is allow you to instantly flip a switch and change from diesel to CNG at a year of your choosing, but you cannot gradually phase in that change. again, that's something we're thinking about for future versions of this tool. And lastly, currently the tool does not have a comprehensive user manual. There are instructions provided throughout the tool, and support will be available from the tool developers. You can email this address below to get assistance. And I do want to make it clear that the EPA is thinking that the current version of the tool, it's fully functional, but we realize that as it gets used more and more, we will identify more opportunities to improve its usability and function. So the EPA is considering putting out a version 2 in the spring of 2018, and some of these limitations listed here may be addressed in that version 2. In particular, the user manual. We think that that's going to be a really valuable addition for version 2. The next few slides provide some information on how you can use Suite. So in terms of navigating the tool consists of about 20 different tabs, and the tabs are categorized according to color. Brown tabs provide notes and instructions and contextual information. The blue tabs are used or where the users enter data. Black tabs provide tables and charts that summarize outputs, and then there are several additional tabs that are colored gray, and these provide kind of more detailed emissions outputs that users may be interested in. In terms of entering the data, as I said, the blue tabs are where the user will spend most of their time entering information, revising information. In each of the blue tabs, and there are, I believe, 6 of them, users must enter data for every cell that is shaded blue. We've tried to color code the cells to make it clear which cells you must fill in order for the tool to work, which cells are optional, and which cells represent calculations. So again, the blue cells must be filled in. This information is used to generate baseline emissions. If they want, users can enter 0 if a data field is not applicable, but we do ask that every one of these blue cells be completed. Users can enter data for up to 4 alternative scenarios, and those alternative scenarios are shaded green. And then users can also override default values, and default values are presented in yellow cells. For the most part, the data required to run this tool should be readily available to cities that are participating in the waste initiative. For example, through the city assessment tool that many cities have completed, much of this data should be available. There are for several of the emission sources, only a few inputs are required. If you remember back to that table I showed, for example, the number of data inputs required to estimate emissions from waste handling equipment is fairly limited. You only need to identify the number of bulldozers or excavators in your city. But in some instances, Suite requires more detailed information, and that's in cases where the data are more critical for quantifying emissions. So in this case, in these instances, we're looking at things like waste generation and collection rates. We ask several questions about how your waste is generated, or what your waste generation rates look like for different segments of your population, what the collection rates look like in the urban areas versus the suburban areas. We ask more detailed questions about waste flow to different diversion categories. How much are you diverting to compost or AD projects or incinerators? The tool asks for fairly detailed information about the composition of the waste that's going to the landfill or different source different diversion categories. Default values are available for the users, but we ask that they pay particularly close attention to the composition characteristics, because that matters pretty significantly for emissions quantification. And then lastly, for the landfills and dump sites, we ask several questions pertaining to the features of the dump site. So when it was opened, when it was closed, how deep the waste is. Those data fields are all really critical for coming up with fairly robust emissions estimates. As I've said before, this tool incorporates a number of default values that users can override. Again, these default values are shaded in yellow, and so if you see a yellow a cell that is shaded yellow and has a value that you think is not applicable to your city and you want to override that value, you can type in a different value and the tool will run off of the value you enter. But if you decide you want to revert back to the original default value, there are buttons that you can click and it will reset the default values. In addition to default values, there are a number of assumptions that are hard-coded throughout the tool, and these cannot be changed. They're protected right now, so you won't accidentally change them. You can view these assumptions and these kind of hard-coded inputs. And these are things like emissions factors for open burning or landfill gas generation variables. You can view them, but you can't change them. And the reason we've held these as protected values is because we think it's very unlikely that many of the cities will have this information for their own locations or localities. And also, we want to be careful about making this tool too overly burdensome, so we tried to streamline the inputs a bit. That said, if we get a lot of feedback on this version 1 saying we'd like the opportunity or the option to override some of these hard-coded inputs, we can consider making those changes. Okay, now I'd like to walk through a few examples that illustrate how this tool can be used to give you a sense of what it can do. And these are just a few basic examples. There are many, many other things you can do with this tool, but I think this will give you a flavor. So for the purposes of preparing these examples, these illustrative examples, we're proposing a hypothetical city with a population of 4 million people, average annual temperature of 16 degrees Celsius, precipitation is 1,000 millimeters. We assume a waste generation rate of approximately 0.5 kilogram per capita per day, waste collection rate of about 80%, and a waste composition that is approximately 65% organic, and that's primarily food waste. There are a lot of other kind of basic inputs that we had to use for these hypothetical scenarios or for these examples, but for the purposes of this presentation, these are some basic facts that you can think about. So in example 1, we're considering the potential benefits of upgrading a dump site. So in this scenario, we're thinking about a site that opens in the year 2010 as a managed dump site. It receives 275,000 metric tons of waste per year as of 2017. The waste is currently 30 meters deep, and we project that this site will remain open until 2030. And what you see in this chart here is a pretty standard curve for methane emissions from a landfill. You see a gradual increase beginning in the year it opens, with a kind of a slowing rate of emissions after the first 10 or 15 years or so, peaking at the year 2030, the year the landfill closes, and then tailing off over the next 20 or so years. It's pretty standard to see curves like this for most dump sites. Emissions for dump sites and landfills don't simply stop when you stop using the site. The organic waste that's deposited there will continue to generate emissions at a gradually reducing rate over time. Now, if we consider an alternate scenario where we convert this site or this managed dump site into a landfill in 2017, so now as of 2017, we begin managing the site as a landfill where we're putting down cover, we are using compaction. We could see in the year 2030, the peak year of emissions, a potential emissions reduction benefit of 1.75 million metric tons of CO2e emissions avoided. And again, after 2030, the emissions will gradually decline out to the year 2050 and beyond. And then lastly, if we consider an additional change where we begin capturing landfill gas in the year 2025, we could achieve an additional 4.85 million metric tons of avoided CO2 emissions in the year 2030. So if you look at the year 2030 and you compare the green scenario to the blue baseline scenario, we've reduced annual emissions by more than 50%. Here's a second example, and this one is looking at reducing open burning. So in the baseline scenario, we're assuming that 50% of uncollected waste in unincorporated areas, and by unincorporated we mean the areas outside the kind of urban center of the city. 50% of the uncollected waste in those areas and 10% of the uncollected waste in the more urban areas is burned in the open. That's the baseline scenario, and so you can see that in this case, in the year 2050, we're getting approximately 1,400 metric tons of PM10 emissions for that year. And I should point out that in this case, we're looking at PM10 emissions, not CO2 equivalent. Now, in an alternative scenario, if beginning in 2017, the city reduces open burning of uncollected waste by half, from 50% to 25%, in unincorporated areas, and 10% to 5% in incorporated areas, you can achieve a reduction of approximately 700 metric tons of avoided PM10 emissions in 2050. And in example 3, we're considering a scenario in which beginning in 2020, a city starts diverting 100 metric tons of organic waste to a compost facility every day. We're assuming that this organic waste stream includes 95% food waste and 5% wood waste. And you can see that if the city continues diverting 100 metric tons daily, beginning in 2020 through 2050, the city will be achieving 100,000 metric tons of avoided CO2 equivalent emissions in 2050. So those are a few examples of how the tool can be used. In terms of accessing the tool, version 1 is complete and will be made available on the CCAC Waste Initiative's knowledge platform. I believe it will also be distributed shortly to CCAC Waste Initiative implementers and partners. Future versions of this tool will be refined based on users' needs and new information. Like I said, we anticipate putting out a version 2 in the spring of 2018, and that version will be we'll try to accommodate or address comments that we receive on version 1 before we finalize version 2. And lastly, EPA contractors, folks like myself at Apt Associates, are available to address questions and comments. We've set up an email account here, suite@aptasos.com. This email address is not yet up and running as of this morning, but it should be later today. So if you do have comments, please feel free to reach out to us. And lastly, I should note that if you're not already familiar with the CCAC Waste Initiative's knowledge platform, there's a link over on the right side of the page. And I strongly recommend going to look at that page and seeing what other tools are available up there. And again, the suite tool will be made available on the knowledge platform shortly. A few concluding thoughts. As I said before, the waste sector is an important source of SLCP emissions, particularly methane and black carbon. Quantifying these emissions can be challenging for a number of reasons, especially lack of activity data, limited emissions factors, and again, the complexity and uncertainties involved in performing these calculations. And the suite tool is designed to help address these challenges so that we can begin to think about best opportunities for mitigating the impacts of the waste sector on methane and black carbon emissions and the associated impacts on health and climate. And lastly, the tool assists cities in prioritizing potential reduction measures and can serve a whole wide range of other uses, like I said, things like benchmarking and assessing performance and informing decision-making about capital investments. Lastly, I'd just like to acknowledge some of the folks who are involved in developing this tool, especially Tom Frankowitz at the EPA. He's been championing this tool, and to a large extent, this tool exists because of Tom. We had several expert reviewers from inside and outside the CCAC Waste Initiative, including those listed here. So I think that's all I have for now. I'm happy to take questions. It seems like we have about 15 minutes left. Aditi, will you be facilitating, or how would you like to proceed?
Thank you, Joe, very much. Well, the questions, if people want to type in the message box, that's one way of doing it. Or if people want to unmute themselves and ask the questions directly, that's another way of doing it. So, questions, anyone? So Marco has a question, Joe. He's written, he has no gray tabs on his suite tool.
Yeah, Marco, I would say that you're probably looking at an older version. We haven't formally rolled out the final version 1 yet. So if you contact me or Sandra, we can be sure that you get the final version. We only just added the extra gray tabs last week.
He says thank you. You can see it as well. Okay.
I see the question from Sophie.
Yeah, you can read it, right?
Yeah, I see the question from Sophie. This is something that we know that taking into account the role of the informal sector is an important consideration. It's something that the initiative has been thinking about. For this version of the tool, we did not include or specifically address the role of the informal sector because we wanted to focus on making sure that the tool was able to perform the basic calculations needed to quantify emissions first. We do think that this is something that we will consider for version 2. I think we'll need some input from experts. I know there were several folks involved in the initiative who have thoughts on this. So I think that's a great idea, and we can reach out to you, Sophie, and others to talk about how we can do this in the tool.
Thank you. So Christopher has a question. Yes, please, can you unmute yourself and ask directly then, please?
Yes, hi, Christopher Sven here from Denmark. My question has to do a little bit with the IPCC AR5, which effectively stopped recommending both global warming potential and global temperature potential in that report. And so thoughts with regards to that. And then specifically when we're looking at short-lived climate pollutants, as we've discussed on this call, and considering, whether they're pulse or sustained types of emissions, but their lifetimes are only 12 years, and then overlay that with global goals of, 2025, 2030, or 2050, comparing it to a CO2 equivalent, especially under a 100-year time frame, do you feel that that's actually an accurate way of comparing these types of emissions?
Yeah, those are great questions. And the issue of metrics and how we compare short-lived climate pollutants to long-lived greenhouse gases, and it's one that we've been wrestling with. With this tool, we've tried to not really get bogged down too much in the metrics that are used, because the tool is designed to produce not just emissions in terms of CO2 equivalents, but also emissions in metric tons for each individual pollutant. So we are using AR4 numbers because that's what the US EPA uses, and also the with black carbon, we're using a 100-year GWP of 910, which came from the Bond et al. Bounding study, which we know a lot of people have concerns about using a 100-year GWP for black carbon. We're very aware of a lot of these issues involved in using a metric to try to compare apples to apples and oranges to oranges, but for the purposes of getting this tool out there, we tried to go with the simplest approach. That said, again, moving forward with the next versions of the tool, this is something that we may want to revisit now that we have the AR5 information, and I think that it's just going to involve more of a discussion, probably at a higher level with the CCAC Secretariat, to make sure that everyone's consistently using the same approach to comparing SLCPs to long-lived greenhouse gases. Yeah. But yeah, no, those are great questions.
In your presentation, you're saying you're using the AR5, so for example, methane 28 to 36, and that's also once again the direct ones. But okay, so it's a bigger decision, because I mean, if you take a 20-year or if you take a 10-year, then making an impact in the waste sector is exponentially more significant to achieve the goals that we're all, attempting to highlight, than maybe other technologies out there. So, for example, from an informative position, whether an individual's composting or landfill gas sequestration, etc., by using different, let's say, multiples of the metrics, it would provide a significantly different viewpoint. Correct?
Mm-hmm. Yes, yeah, and maybe what we could do in version 2 is
have like a 5, 10, 20 year that you can look at different timelines.
Yes, and allow the users to toggle different metrics, whether you want to use the GWP 10, 20, 100, or the GTP, or some of the other newer metrics that I'm less familiar with. But I think that's a great point. Especially with methane, where it is a little bit easier to quantify the radiative impact, or the radiative forcing associated with emissions. Black carbon is tricky. A lot of people object to using global warming potential for black carbon in general because it is so geographically variable and right now we're using a global average of 910, which again we agree that it's a shortcut, but maybe for future versions of the tool we can spend a little more effort trying to dig into those nuances more.
Can I ask a follow-up question? I don't know if there's other questions, but I have one more.
I don't see any other questions in the box, so.
Go ahead.
Sorry, go ahead.
I think you can go ahead, Christopher.
Okay. So my question was going to be, looking at landfills, do you guys consider landfills to be pulse emissions or sustained emissions?
I would have to defer that question to our landfill gas modeler. I can get back to you on that if you're okay with that. I personally do not have a good answer for that.
Okay, fine. And in your example 1, where you're looking at the dump site that then becomes a managed dump site in 2017, where it's open in 2010, is that the typical timeline for landfills to start, let's say, gas or capping and then gas sequestration?
Yeah, in this case, we're saying that if they begin applying cover, so converting to a landfill in 2017, there's an additional 8-year gap before they begin capturing gas. Yeah. This was just we wanted to have an example where it was very clear how the staging of the process. That 8-year period is not necessarily a rule of thumb.
But I think this is a great example in that context, because especially when we're looking at methane, let's say that the methane predominantly starts to happen, or at least for the garbage that's dumped between 2010 and 2015, a majority of that greenhouse gas potential or biogas potential occurs within the first 2 years, if not, less, plus minus, right?
Mm-hmm.
Okay, fine. That's all from mine. I'm muting again. Thank you.
Okay, great. Thank you, Christopher.
Thank you, Christopher. Any other questions? Please go ahead. Feel free to ask aloud or just type into the box. So Tom's asked a question, Joe.
Yes. The answer is yes. The tool does allow you to consider a baseline and up to 4 alternative scenarios with anaerobic digestion plants. That said, it is not designed to allow you to evaluate different anaerobic digestion technologies. We felt we considered that and felt that it would be adding a little too much burden to this tool. So that's it. It does allow you to evaluate alternative scenarios, but the only levers that you can adjust when comparing those scenarios is how much waste is going to anaerobic digestion and what the composition of that waste is.
Thank you.
Looks like Marco is typing.
While Marco is typing, how can private individuals or private companies get involved in the further development of these types of tools, if that's of interest or not?
Yeah, well, I can't speak to all the tools that the Waste Initiative is producing generally, but speaking as a contractor for the U.S. EPA, the EPA is in its role as a lead partner in the Waste Initiative, is very interested in getting outside expert input on the tools that the EPA is supporting. So in cases like this suite tool, if you are interested in being an expert reviewer, the EPA is happy to work with you, to work with individuals, even if they are outside of the Waste Initiative family. This is one of several tools that the EPA is developing. We are working on developing a model for estimating the costs associated with organic waste management projects called Organics. We've also developed a screening tool for looking at the technical feasibility of landfill gas projects. And we're actually in the process of potentially developing a couple tools related to anaerobic digesters, helping cities screen for potential projects and also manage operations at existing AD projects. So from EPA's perspective, there are a number of tools that the agency is developing on behalf of the initiative, and EPA looks for opportunities to engage with experts in the field to help improve the usability and function of these tools. So I encourage you to reach out if you'd be interested in assisting.
Great. I see Marco is still typing. Okay, I'll hold off.
So Marco has written he needs an updated version of the tool, as some of the columns on the sheet collection and transport are hidden, is what he says.
Yes. Yep. And the updated version, those formatting glitches have been resolved. And so, like I said, the updated version, or the final version 1, should be available on the Knowledge platform soon. I can't say specifically when. It's just a matter of posting it up there. But if you are interested in receiving the tool directly when it becomes available, you could email the email address that I put up here. But I would ask you to please wait a day or so before sending an email to this address, because it may bounce back. We're still setting it up. What I can also do is provide my personal email address here in the text or the chat window, so that if you do reach out to the suite@aptassos.com email and it bounces back, you can always reach out to me directly, and I'll make sure that you get a copy of the tool as soon as it's available. I see Marco made a comment, the scenarios for composting. Yes, that is correct. The general information tab, and I understand that many people here have not. Well, actually, let me see what I can do here. You should still all be able to see my screen. Marco was asking if the scenarios for composting in AD need to be defined in the general information sheet, and that's correct. In the tool right now, in the general information sheet, we have a section on baseline waste flow. And so what the user needs to do here is start designating how much waste is going to facilities of different type per year, whether it's composting or AD or combustion recycling. And we ask that you provide that information for a baseline scenario. So for composting, you may say that beginning in 2020, we want to begin diverting 100 metric tons per year. We're going to have 95% food waste, 0 green, 5 wood. And that's your baseline. Further down, we ask for waste flow for the alternative scenarios. So in alternative scenario 1, which you can call, composting increase or something like that. You can provide a description, and then here you would say, all right, for our alternative scenario, rather than composting in or initializing or beginning to compost in 2020, we're going to start in 2018. Whoops, has to be, sorry. We're doing 2020 still, and we're going to divert an additional 100 metric tons per year. So now we're diverting 200 metric tons. We're still doing 95% food waste, 0 green, and 5% wood. And that's how you would analyze the alternative scenario. I can't flip over to the results right now because I haven't gone through and entered data for all the other essential cells, but you can see that the tool will provide a large number of charts that you can pick from. And the charts are, there's some macro buttons here that allow you to select which charts are visible. So for example, if you just want to see your, let's see, so black carbon, PM. If you just want to see, oh, those are burning. Sorry, I shouldn't have gone into this. I wasn't ready. So you can look at the methane emissions, for example, from your overall, all the different scenarios, and you can compare your baseline scenario to the composting increase scenario. The scenarios 2 through 4 are blank right now, so you can drop them. But anyway, I wasn't prepared to run through that example, but that gives you a sense of what it would look like. So the amounts. Yes, Marco, to answer your question, in the alternative scenarios, you are providing the additional quantities relative to the amount diverted in the baseline. It's possible that the version of the tool that you're looking at right now does not make that clear. This is a change that we only made just about a week ago. So when you see the final version, it should be clear. Okay, great.
So thanks a lot, Joe. If there are no other questions, we'll go ahead and close the webinar. It's been, I think, a very interesting introduction to the suite tool, and I'm sure people are going to reach out to you. Thanks everyone for participating. We will make the presentation as well as the link to the recording and the tool available shortly. And I hope you'll join us for the next webinars that are going to be held in November. Till then, have a lovely day and see you soon. Thank you.
Thank you.